Hi once again, it's Matthew here. Now, in recent times, you may have seen on some of my videos that I've been getting much more into the whole electronics thing, DIY stuff. And you may have seen my video that I did a few weeks ago about this thing, which is the Look Mum No Computer Fart Box synthesizer, which I had great fun building. Now, since then, I've built a few other things. I've built this thing here, which is the Look Mum No Computer 20 drums, which I will show you a little bit about how I've built that in a minute. But then I've also built these two things here, which is the Look Mum No Computer basic oscillator and the filter that he did a circuit for based on the circuit from the Korg MS-20. Now, all of these things I've thrown together with not a huge amount of money, and it's just been great fun. So what I'm going to do is show you a little bit of what I've been building, and I'm going to give you a little sound sample of how this thing sounds. Now, I'm no sequencer, I'm no keyboard player, never have been, I'm a guitarist, but you can have an awful lot of fun with this sort of stuff, even if you're not that musically inclined, as long as you've got something to control it. And for that, I've got this thing here, which is the BeatStep Pro, which is a really great step sequencer. It's got lots of connections on it for wiring into different analog and MIDI devices, and without too much trouble you can be making music really quickly with this little setup. So what I'm going to do first is I'll just show you how I built this one here, and I'm going to then give you a little bit of a sound sample at the end. Well, this is the other kit that I bought, and this is called the Twin Drums. And in essence, it's based on the practical electronics circuit that was published in the mid-70s to build a drum machine. And it kind of has the same sort of sounds as drum machines, such as the Acetone Rhythm Ace or the Roland TR-77, the Boss CB55, which I built a clone of made by Circuit Benders, that kind of sound. And there's actually three circuit boards. You've got the control panel board here. This board will hold all the jack sockets, and this is the board with all the components on. And in essence, they all sandwich together and they make this Cosmo module, which is a 20mm length board. And the idea is that you can build your own cabinet out of wood and mount these modules in and build a modular synthesizer. With these synths, they all run on a Eurorack power supply. And I don't have a Eurorack power supply, but I bought this. Well, this circuit board is made by a company called Frequency Central, and it basically gives you a plus and minus 12 volt DC power supply, which is standard for Eurorack type equipment. Now, this circuit is more or less the same power supply circuit that's actually in the Fartbox synthesizer, and it's the same power supply here that you see in the Music 5000 clone. Here we have then all the parts I need to build this power supply. Got 6 chunky diodes there for rectification. We've got our smoothing caps, we've got some more capacitors here, we've got our DC inlet, our LEDs, and the heart of it are these 3 regulators. You've got a plus 12 volt regulator, a minus 12 volt regulator, and we've got a 5 volt regulator as well. So we get all our power all off this board. Well, there it is, all assembled. Now, there should be some heat sinks on the regulators because it is recommended, because this board is designed to drive a lot of modules, although at the moment I'm only going to use one. And I'll probably just bolt some bits of aluminium or something to them, and they'll be fine. But as it is, I'm only going to use one module, so it should be fine. Next thing then is just to make a simple power cable. I've got the larger size multi-way connector there and the smaller size one for here, and I've got some cable, and I will just do a simple crimp that uses this side of the connector and marries up with this side here. This is the crimping tool that I will use. It's about £20 when I bought it, but it is really useful and it does do a nice job of getting all the wires crimped in the correct position. The actual plug fits in with this little groove in here, and it's all neatly in place, it's all lined up correctly. So we just do this, and there we go. That's crimped in place. I'll just cut off the excess. And then I can flip that over the top like that, with the red line always to there, and then pop this little clip on the top. And then what I'll do is exactly the same thing with the smaller connector. Sometimes it's easy just to do the simple bits first. This is the board for the jacks. It takes some resistors here that are all 1K, and there's a multi-pin connector there for connecting it to the other board. So the first thing I'll do is I'll put in all the 1K resistors, and then I'll solder in the jacks. As pig's ears go, I made a real pig's ear of this one. Not only did I get those sockets on the wrong side of the board, after I eventually got them off the board, I then resoldered them in exactly the same position again. So I had to desolder them again. Now on the first desolder, I damaged a pad, so I've had to put this little bit of wire in to go up to the top jack, although I might resolder it and make it a bit neater. Anyway, everything's mounted on the board now. Another thing, it's always best to put the jacks actually in place first with this panel before you solder them in, and then that way they will fit neatly. As it is, a couple of them are at a funny angle, so I may have to resolder them. But anyway, I've done a continuity test between the main pin of each jack on this side to the corresponding pins here. That works okay. And on this side, because you've got a 1K resistor as a buffer, then I've just done a continuity from the pins to the resistor, and yeah, everything's good anyway. And on this board, I've soldered in the pins to connect it to the jack board, and I've also soldered in the power connector. So the next thing to do is I'm going to start populating the board, and I will do it in the same way that I've done all the boards, where you do the smallest components first, so resistors and diodes. I then put in the slightly larger components such as capacitors, and then I put in things like all the IC holders and everything else, LEDs, and then the board will be made. Now what's interesting about this is there's a few resistors mounted on this side of the board as well, and you have to solder those in first, because actually a couple of them fit, like for example here, they're actually underneath a IC holder, or at the bottom of an IC holder. So yeah, so the ICs I think go on this side of the board, but there's, oh I see, you've got the resistors here, and so you put them on this side of the board, and then they don't intrude. So it's just a way of compacting everything onto the circuit board. So it's a nice little design Sam's done anyhow. Now I always feel good progress is made once you've got all the resistors in, and as you can see here, all the resistors are now in place, and there's actually some resistors that are mounted on the base of the circuit board as well. And yeah, I spent a couple of hours doing those, just trying to get them in nice and neatly, and now they're in there. So the next thing I will do is mount all the diodes, of which there's quite a few, and I will then start mounting any transistors and capacitors. I did pop a little regulator in there just because I happen to have my box of regulators out at the time. And once all those components are in, it's going to be just mounting the IC holders, popping in a couple of chips, and then I think we're going to be ready to test and calibrate. So yeah, next thing to do then is diodes and capacitors. Well, I was so chuffed with how I got the Twin T drums module here to work. I decided to do a little bit of carpentry. So I've got some wood here, and I've mounted the power supply in the back there, and I actually made a slightly longer power lead with some more plugs on the end of it to run some more modules. And then I built some more modules. I built this oscillator here, and then I built a filter to go with it. Now the oscillator, if I turn this around, it's just a basic strip board circuit. It's using the same chip that's in the Fartbox Fartbox synthesizer, not computer. And there's a couple of op amps in there as well. That pot there is used to tune the oscillator, and it all works on this little module here. And after I did that, I then decided to build the filter, which is using a couple of op amps there. And then I mounted them to some scrap bits of metal that I had. I mean, it's not particularly elegant, but I just painted it with some hammerite. And there were a few random holes in some of these bits of metal, which I reused for some of the pots and jacks, which is why they're not particularly lined up very well. But there it is, that is my first modular synthesizer that I've ever built. I've got a little bit of space here that I might put an envelope generator or something else in, although I have a feeling I will need to get those heat sinks on those ICs, and then I will need to mount this in a bigger box because there'll probably be more bits and bobs coming along in due course. But I've got to say, these circuits that Sam's been putting on his website, they work and they sound good. So if you want to try experimenting with building your own analog synthesizer, then look up Look Mum No Computer. The circuits are all there. He's made videos about how to build these things, and if you want to build other modules like the drum machine, then you can buy the PCBs for those as well. Okay, this is quite a crude setup I've got for this demonstration, but in essence everything's being controlled by the BeatStep Pro. Here I've got my oscillator and my filter. The twin T drums are here in the rack, and then I've got the fart box here. Now if I fade up the oscillator here on this control, you'll just be hearing a buzzing noise. That's because there's no gate, no ADSR, so it carries on playing until I change the note. And I can go down an octave, right down to the bottom, so that's the lowest note I've got at the moment. So that's the highest octave, go down 2 octaves, that's kind of a medium octave. Now this probably isn't exactly in tune because we've got the coarse tuner here, which you can turn out. So I've got a note there, and then we've got the filter here. So that's adjusting the level of the filter, and then we've got this resonance control here, which kind of has more of an impact with a square wave. But you can hear it's doing something there, but this is the main thing here. So we've got that playing away, and then if I go to sequencer 2, that's controlling the Look Mum No Computer fart box over here. So what I'm going to do is I'm going to leave that droning there on the first note, which is like, well, it says it's a C, but it probably isn't. And I'll go to this keyboard. What do you know, it's in tune. In fact, if you've got it on the same note, it's got quite a nice fat sound to it. So yeah, that's working quite well. If you're listening to this on headphones, by the way, you should be hearing this synth here coming out. Let me get it switched on. You should be hearing this synth favoured to the left hand, and that should be coming out on the right side. And slap bang in the middle of this, of course, we've got the drums, which are, there's our kick drum there, there's our snare drum, there's our clav sound, which if I turn this up a bit, it doesn't really do a lot. That's our low bongo, that's our high bongo. Now, when Sam designed this, he's put separate jacks out for each sound, which I think is a really good idea, because actually you do need to kind of adjust the levels a bit on this, particularly with the clav, which is sort of drowned out a bit. But if I put in a basic pattern, so I'll stick this on the 16s and hit play. So that's giving us a nice, good sort of traditional 80s drum pattern there. And then I'll go to the original, the synth here. And I might just put a riff in. So we've got that going there, and then I'll get into the next keyboard sound. And then once you've got something playing quite randomly like that, then you can start messing around with, you know, filters and things. And go higher. That's sounding quite funky. That's just the fart box doing that. So I might switch the other sequencer over now, get it playing. So I'll start that recording. And then of course, if I want to just change the tempo of everything, you just turn the speed control down or up. Or I'll slow it right down. It takes time to get good tunes out of all this sort of stuff, but I hope that little demonstration just shows you that there is potential here for some really exciting, fun stuff to be had without, you know, breaking the bank in electronics. I mean, if you were to build this sort of stuff, even 20 years ago, you wouldn't find the diagrams, you wouldn't find the parts, and literally I just threw all this stuff together and it seems to make a good noise. So I hope you've enjoyed this video anyway. And if you do, please like and subscribe. But also, I wouldn't be doing any of this if it wasn't for Sam and Look Mum No Computer. So make sure you subscribe to Look Mum No Computer, because he's got some absolutely brilliant projects going on over there. And you can literally just learn so much about how this stuff works. So anyway, hope you've enjoyed it. And if you have, please like and subscribe. And see you for the next one.